Stuart, we're down at Dassi HQ.
Yep.
Dassi's been going now for 5 years.
That's great.
I think you could just tell us a little bit of the journey, as much as you can, the 5-year journey to get us here today.
Wow. It started 5 years ago with an idea with a personal trainer for doing a triathlon, and rather than actually going and buying a bike, I decided that I could make one better, and so did. Having cut up 5-6 bikes on my kitchen table and delaminated them with a blowtorch in order to count the layers of carbon made, and eventually we get to the point where we're re-importing a bike that we designed and changed back into the UK. Moving on very quickly, sort of 3.5 years on from that, we get to the point where we've found out how to make them in Britain, who we're going to make them in Britain with, and nearly a year ago now we actually set up a facility to physically manufacture here in the UK, and we make through the F1 supply chain, which basically means you get a very highly skilled workforce assembling carbon composites and hyper composites in a very unique way, but here in Britain, and I think that's pretty unique.
You just mentioned before off camera, I mean, the different components come from different parts of the...
Yeah, so the frames are made in Banbury, the seat post clamps made in Aldershot, the bottom brackets made in Leicester, the cable exit ports are made in Aylesbury, the custom spraying that we do is done in Camberley, and then we assemble everything here at Dassi HQ, which is in Hampshire. So yeah, there's not much that doesn't happen in the UK now. On top of that, our research is also done here in the UK through PhD students at Bristol University, and we also have collaborations with 2 graphene companies that help us do R&D as well. But as graphene was a UK invention and predominantly is manufactured here in the UK, that also means that the material in our supply chain is now UK as well, rather than being imported from the Far East.
And that brings us nicely onto graphene. I mean, some readers will know about it, but I mean, can you give us a little bit of history about graphene? And I know you've got some with you.
Yeah. So this is graphene in a jar. It's about £5,000 worth of graphene. That would make a lot of bikes. 1 gram of graphene is enough to cover a football pitch at 1 atomic layer thick. So you don't need a lot. The way that it's made is through impregnating the epoxy resin with the graphene, and then you insert your fibre into that epoxy tray and functionalise it so that the graphene is distributed evenly across the carbon fibre. That's all happening in the UK. Graphene has some very unique properties. It's 200 times stronger than steel, it's 10 times tougher than diamond, it's hyperconductive, so that basically means that it will pass a current or a voltage. It's hydrophobic. There's only one plant in the Amazon that is more hydrophobic than graphene. It's super strong, so as a consequence you can use less of carbon material, roughly 25 to 30%, so that means you can make lighter products. It's pretty special stuff. In essence, you could create a carbon graphene lacquer and spray a house brick and stick that in a wind tunnel, and it would instantly be more sort of aerodynamic, just because nothing sticks to it. There'll be a little bit more to it than that, but in principle it would work. We're utilising the properties of graphene, though, not because of the weight reduction. We're seeing that as a byproduct. What we're most motivated by is the hydrophobic properties and the electrical conductivity, which is part of our strategy is to create an intelligent bike that will begin to interact with the clothing, interact with the human being, and then actually start to make suggestions in real time as to positions on the bike to optimise your power. And we foresee that actually coming to a reality in the next 6 months.
Wow. And it's a strange question, but did graphene find you, or did you find graphene?
I found graphene through reading a lot of research papers, and then I reached out to a couple of graphene suppliers, and we did some prototypes and things like that, and eventually got to the point where we now have a considerable amount of graphene in storage, ready to produce bikes.
Yeah. And in terms of producing bikes, is it much different from carbon bikes? Is there a longer lead time?
There's not a longer lead time. It's much more complex to make a graphene pre-preg, and you also have to work with it quicker. So you can lay up in exactly the same way, but you do need to work with the material faster, because if you like, the half-life of graphene it is much less than standard carbon. So you've got to get it in the mould quite quickly at room temperature, otherwise it will go off. And that's one of the challenges. So it's difficult to make in its raw powder form. It's then difficult to impregnate into a carbon structure, and then it's difficult to actually work with. But if you can get all that right, you can end up with a superior product, and it's superior in a number of different ways. It creates a stiffer frame, which means that you can get more power through it. As you lay up carbon, the interface between the layers of carbon is known as an interface. That interface has a shear when you're basically putting stress through a frame or any construction. It's called interlaminar shear, that, and what graphene does is decrease that ability to shear apart by 78%. So it's a huge increase in the bonding surfaces, if you like, between the sheets of carbon that you're pressing together and then using that epoxy to glue together. It's also got better fracture toughness, so basically it's a lot harder to crack it, and because you're dealing with an atomic level lattice structure, if you do get micro cracks, they tend to get held within an atomic structure, so that they can't actually grow or propagate in any way. So you get crack retardation as a byproduct of utilising graphene, even if you weren't looking for anything else. So there are many benefits to utilising it as a product than just, I'll get a 20% weight saving. That's a byproduct.
And we have got a product. We've got the Interceptor. This is the first. The
Interceptor
bike.
G, which is the graphene version of our carbon frame product. This is currently the only one in the world right now made out of graphene. We've got 25 others being made right now for customers all over the world, from the US to the Middle East, all over the world they've been bought, and the first 25 are being delivered in a unique way with certified certificates and things like that before we go into mass production. And then when we move a mass production from a Dassi perspective, which is nothing like any of the other manufacturers, but and then the next step is that we'll start to introduce service packs, so an electronics pack, a lacquer pack, etc., so that we can begin to offer enhanced product to our customers.
Yeah, I mean, I chatted to the Haydale guys who are running some of the technology. I mean, I don't know if you can talk us through some of that, some of the things you've got planned with
Yeah, so in its simplest form, it would be nice to know in real time the deformation of a frame as a rider is riding it. The UCI standards for testing of frames are pretty basic and over-engineered, and you can't compare that for every single rider, so it's generic, but you're a singularity, so why would you want something that has been defined for everybody else? You want something for you. So our vision is to have a system set up in such a way that we can collect that data and do carbon layup specifically for you based on that data that we get back and analyse. That's part of a journey, and that journey for me is probably a year to 18 months long, and would see an intelligent bike being delivered that is communicating with intelligent clothing and is giving the rider information that hitherto they've never been able to get. And if you were to transpose that into the Tour de France or something like that, it would be great to sit there and understand what is exactly happening to Chris Froome on a bike. What is his sweat ratios? What's happening with his power? How much is his frame twisting, deforming? How much is he accelerating or decelerating? And get all that data like you can in F1 and have that on a screen. Well, you could do it for the whole peloton. You can then see what they're all doing. It gives you a whole access to a level of analytics that just doesn't exist. That would make it more interesting.
Certainly does sound. It sounds fascinating, and all from a kitchen table.
All from a kitchen table, and all from this black gold.
Yeah. Well, thank you very much for your time, and we look forward to seeing the journey continue.
Thank you very much.